In this section, we're going to talk about some more types of equations. These equations are called literal equations. And literal equations are equations with several variables in them. And you want to solve for the given variable that you have. This is very applicable, particularly in the sciences, like in chemistry, where you have a formula to work with and you need to solve for one of the variables in the formula. So let's take a look at some examples here of how to solve literal equations. So you notice that I have this equation here, y equals 5x minus 6. And the goal here is to solve for the variable x. So it's similar to what we've always been doing. We're solving for the variable. But you notice that we have another variable here. We have y. So try to keep the idea of, your focus on doing all of the steps that we've been doing this entire unit and just solving for that variable x. So I'm going to start this problem off by getting rid of the number that's not attached to the x. And I'm going to go ahead and I'm going to add 6 to both sides. When I do that, on the left-hand side, I'm actually going to have y plus 6. I know that's kind of strange to have another variable. And I'm going to have that equal to 5x. And these two are additive inverses, so they're going to eliminate. And now I just want to go ahead and I want to solve for my x. And just like I would in a regular equation, I would divide both sides by 5. So I'm going to go ahead and do that. When I do that, my 5's eliminate. And I am left with x is equal to, and on the left side I have y plus 6 divided by 5. Now I know that might seem a little uncomfortable, but this right here is what x equals when you solve for that variable. It's not going to necessarily equal a really nice number like we have been working with. It's going to equal just another expression that might have variables and numbers. Okay, let's solve for h in the next one. It's being multiplied by pi r squared. You'll know you might recognize this formula here, and we just want to solve for the h. We want to get it all by itself. So since the h is being multiplied by the other two things, I can actually do this nifty thing. I can divide both sides by pi r squared. Watch what happens when I do that. My pi's will cancel out, and my r's will cancel out. And that gives me my h by itself. So my final answer will be that my h is equal to my v, which is my volume, over my pi times my radius squared. And I just solved my literal equation for my variable h. Let's solve for b in the next one. Now we got to dig a little bit deeper here for the b. Now, notice that the b plus c is in a quantity. So I can't, right off the bat, move the b over to the left side or anything. I have to kind of work my way inward. So I'm going to get rid of whatever's on the outside of that quantity first. And I'm going to go ahead and divide by h because right now he's being multiplied. So I want to get him out of the way. When I do that, I'm going to end up with a over h is equal to b plus c. Now, b plus c is a quantity, but at this point, there's nothing outside, so I can just write it without the parentheses. And I want to get the b by itself, so I'm going to go ahead and I'm going to subtract c from both sides. I know it might feel a little uncomfortable, but we're going to get an answer of a over h minus c is equal to b. And if I put my variable on my left-hand side, I'll have b equals a over h minus c. And we solve for my variable. Okay, and the next one we're going to solve for y. I got to kind of work my way inward towards the y. So I'm going to first begin by getting rid of my denominator so I can kind of work my way upstairs. My 2's will cancel out. And I'm left with 2a is equal to x plus y. All right, I want to get y by itself, so I'm going to move that x over to the left-hand side. I'm going to have 2a minus x is equal to y. And I always put my variable on the left-hand side, so let's go ahead and do that. Y equals 2a minus x. And I just solve for y. All right, let's bump it up a little bit and do some more problems. All right, for this one, I want to solve for y again. I've got an x in there as well with some numbers. So let's kind of work our way around. I always try to kind of start on the side that has the variable that I want, and I get rid of everything else that's kind of like in the way. So 12x, that is definitely in the way of getting 4x or y by itself. So I'm going to go ahead and get rid of him, and I'm going to be left with negative 4y is equal to 20 minus 12x. And of course I want to get my y by itself, so I'm going to go ahead and I'm going to divide that side by y, and I'm going to divide the other side by y. And when I do that, I'm going to get y equals, and if you remember from Unit 1, we talked about simplifying this little type of problem. Just to kind of a refresher, I can circle, this is one problem, 20 divided by negative 4, yeah, that's going to be negative 5. And then I can take my negative 12 divided by my negative 4, and that's going to be positive 3x. And I solve for y. I'm all done. All right, in the next problem, I want to solve for z. So z is in the numerator, so I got to kind of work my way up there. So I'm going to start by multiplying both sides by 6. That gets rid of that denominator to make everything a little bit easier to work with in the numerator. I want z by itself, so I'm going to go ahead and I'm going to get rid of y. I'm going to move him by dividing him. So I'm left with z is equal to 6x over y. Now, in all these problems, just because I'm asking for this variable, it doesn't mean that I can't solve for another variable. For example, in this problem, I could also ask to solve for y. That's fine, but in the directions it said solve for z, so that's why we did that. All right, let's go ahead and solve for a in this next one. Again, he's in the numerator of the fraction, so I need to work my way up there, so I need to get rid of that denominator. So I'm going to go ahead and do that. Okay, and I'm trying to get a, so I'm going to go ahead and I'm going to get rid of my 2y by subtracting him from both sides. And I'm going to have 4x minus 2y is equal to, now be careful here because 2y, they cancel out, but I still have a negative a. And I don't want negative a, I want a. So I have to divide both sides by negative 1. So when I do that, I'm going to get negative 4x plus 2y is equal to a. And I'll rewrite that for us. I'm going to put my a on my left-hand side. And there is my answer. All right, one more on this slide here. Let's solve for x. Okay, now I have a fraction here. Again, a denominator. Get rid of that denominator. Multiply both sides by 2 just to get rid of him. See, now he's gone. So I have 2y. Actually, that's a capital Y, so I'm going to keep him as a capital Y. Excuse me there. Okay, so I have 2y is equal to, I got rid of my 2's, so I'm left with 1xbl. So I don't really need to write that x, that 1 there. I just need to write xbl. And I'm trying to get x by itself, so I'm going to go ahead and I'm going to divide both sides by my bl. They eliminate on that side, and I'm left with x is equal to 2y over bl. Excellent. Okay. Now, some unique types of literal equations here. What happens when you have two of the same variables in an equation? So, for example, solve for r, and I have two r's. Well, this is a little technique I like to call undistributing. So, let me show you how it works. I'm going to say that s is equal to, and I want to solve for r, but I have two of them. So here's what I'm going to do. I'm going to pull out an r from both of these terms. If I pull an r out of the first term, I'm going to be left with a 1. And if I pull an r out of the second term, I'm going to be left with a negative g. And you can always recheck yourself by redistributing your r. So r times 1 is r, and then r times negative g is negative gr. So now that I've undistributed the r, I have r kind of by itself. So what I can do here now is I can divide both sides by 1 minus g. And watch what happens. My 1 minus g, they cancel each other out. So now my r is just equal to s over 1 minus g. Here's another example, but this time the x is not only on the left, but it's on the right as well. So what I want to do is I kind of want to put them all together. So let's go ahead and I'm just going to do this. I'm going to go ahead and add xy. Just to get my x's on the same side. I could have subtracted 7x. That would be fine as well. So I'm going to get 7x plus xy minus 2z equals 4. Excellent. Okay, now I want my x's to be by themselves, right? So I have two terms with x's. I'm going to go ahead and get rid of that other term, and I'm going to move him to the other side because I don't really have anything to do with him. Okay, now let's do that undistribute thing. Let's pull out an x. I'm going to pull out an x, and if I pull out an x from the first term, I'm going to be left with a 7. And if I pull an x out of the second term, I'm going to be left with a positive y. And on the right-hand side, I'm just going to have everything else that I've already established there. So you see what we're going to do here? We're going to go ahead and we're going to divide by 7 plus y, because that's going to eliminate that 7 plus y from both from the left-hand side. That leaves me with the variable that I want. I wanted x by itself, so x equals 4 plus 2z divided by 7 plus y. And I'm done. All right, two more challenging problems here, and that will be the end of our lesson. So let's look at this formula here. Solve for t. T1. So you can see T1 is in my bottom numerator. And let's see what I want to do here. Couple things I could do here. First of all, let's go ahead and get him out of our denominator. I think it's a great place to start. Let's go ahead and start there by multiplying both sides by that T1. So when I do that, they're going to eliminate on this side, and then I'm going to be left with P1V1 is equal to P2V2 T1 over T2. All right, excellent. Let's get rid of that other denominator because now I need to get my T1 from my numerator. So I'm going to multiply both sides by my T2. That's going to get rid of that denominator, which is what I wanted. And so on the left-hand side, I'm going to have P1V1T2 is equal to P2V2T1. And I want T1 by itself. So I'm going to go ahead, and these are all being multiplied, so I'm going to simply divide both sides by that P2V2. And when I do that, watch, they cancel out, and I'm left with that T1. So my T1 is equal to P1 V1 T2 over P2 V2. This is actually a common chemistry formula that you'll be working with in high school. All right, in our last problem here, we have solve for x. Okay, x. X is by itself. He's way in here. So let's go ahead and figure out how we're going to get there. Let's go ahead and get rid of the m first. Let's go ahead and divide by m. Dividing by m eliminates him. So now I'm left with y minus y1 over m is equal to x minus x1. And I want x by itself, so let's go ahead and I'm going to take that x1 and I'm just going to go ahead and add them to both sides. I'm going to add x1 to both sides. So I have y minus y1. I'm going to take them out of the parentheses over m plus x1 is equal to x. I could rewrite that with my variable on the left-hand side. And I'm done. I found my variable. I could have also solved for y1 or y or m or any of those variables. All right, that is the end of the lesson on literal equations.